Hi, and welcome to Tea Leaves Programming. Today we're programming like it's 1979, doing Haskell for dilettantes. We are doing Chapter 2, or Lecture 2, excuse me, of the MOOC, massively online course at haskell.mooc.fi. There are two problem sets here, 2A and 2B. Chapter 2 introduces the rest of, I shouldn't say the rest of, but much of the syntax that I was ruining not having last time. So guards, case expressions. It also talks a bit about immutability and type inference and polymorphism. I'm not going to go through the lecture notes and try to teach this course. This series that I'm doing right now is just doing the exercises and sharing some of them with you. As I mentioned in the first video of this series, I'm not doing all the exercises on video. I'm basically doing all of them myself and then sharing the highlights with you. Is palindrome. God is my witness. I wrote this the other day for some reason or other. I can't remember. I think I was trying out some feature in some language. I was like, I'll do that. All right, so is palindrome. This is one where a little bit of pattern matching helps, right? If we have the empty string, it's a palindrome. If we have one, let's do it this way. If we have one character attached to the empty string, an empty list, that is also a palindrome. And so those combined, I think, are our base cases. And there's a lot of ways to do this. Let's do this just to annoy people who like one character variable names. First and rest. The first character and the last character in the string. What's the best way to get the last character in the string or in a list, as it would be? We could reverse the list and take its head. Or we could do, drop length -1. And that would leave us with, that would leave us with a string still. So I think reversing it and taking its head is actually the right thing. And we know for this case that we can do that because we have more than one character in the list. Okay, so this is going to be, could use a guard here, I'm not going to. If first is the same as the last, then, but the problem here is that to do this algorithm this way, we would also need to, once we've done that comparison between first and last, we need to then remove the last one from the string if we want to shorten it that way. I think we could still do that. Then, is palindrome first attached to right? We'll do a let. I said I was going to practice more lets. Let last equal. What is last going to be? Last is going to be let. And I am binding that R2 to a variable for a very specific reason. It's going to be okay, so we're reversing rest. We're binding the first character of that reversed string to this character last. And then we're binding the rest of it. And that is going to be our truncated. This is, I'm going to be honest, this is too clever by half, but, you know, live a little. All right, I'm going to be interested to see if that works. I'm sure there's some really simple case that I've managed to forget here. This one I want to try in the REPL. Parse error in pattern. I guess I need a parentheses. Also, I need to align these because, as I said earlier, I'm very type A. Okay. Okay, so it doesn't work. Well, that's correctly wrong, or correctly false. That's correct. That's not good. So what's going on there? Clearly I've failed to take account of some obvious case. Can I think my way through it, or do I need to, like, print stuff? Oh. Okay, well, there's one problem right away. I've put first back on the list. After making a big deal of taking that off, I'm like on the verge of trying to add trace debugs to see what these values are. But let's just see. Okay. Make sure we didn't break the false case. We didn't. All right. And that's exercise 5. Safe list indexing. Define a function safe index so that we either get the element at index I, and if I is not a valid index, nothing is returned. And we can see here it takes a list and an int and it returns a maybe. So this, I think, this is a case where we're going to do guards. If I is less than 0, nothing. I'm actually going to look up the guard syntax because it's been so long. Yeah. Nope, that is not right. Guards use the equal and not the arrow. And if I is greater than the length of the list plus length of the list minus 1? No, if I is greater than or equal to the list length, then it will be a problem. Every other case, this I should be valid at this point. So at this point, we can say just access I. Normally, that's an unsafe operation, but the point of this is to convert it into a safe one. And as long as we've handled all of the corner conditions, that should be true. Yay! That's exercise 9. Let's move on to step 2b. Don't add other imports. So if we see a way to do this with some library function, we're not allowed to use it. Exercise 1, compute binomial coefficients using recursion. They are defined by the following equations. K is greater than 0. Wow, I don't understand that at all. A lot of mathy stuff, but you know, following the types and using pattern matching can let us bluster through things we don't understand. It's kind of a superpower. So let's do the simplest case first, which is If our k is 0, then we've got 1. So I think this looks like, is it called a co-recursive function? No, it's not a co-recursive. It's like a recursive function that's recursive in both of its arguments. So it's not going to be tail recursive. At least out of the gate, there's probably a way to do this where we use an accumulator, possibly a helper function. So if this is 0 and k is greater than 0, okay, again, this is one where they don't explicitly say that k has to be positive, but I think it has to be, because by definition, Bn of k is going to go to k minus 1. So if we assume that k can be negative, the algorithm will never terminate. So I am assuming that k has to be positive. Okay. So therefore, if this is 0 and this is anything, I've eliminated the negative cases. I've handled the 0 case here, and therefore this is positive, then this is going to be 0. So I think this is why they presented these in this order, because in order to do this with pattern matching, you need to realize that these are more specific cases, and they should be coming first. So that leaves us with this. And at this point, this should just be a recursive call, because we've handled both of the base cases. So that's going to be, let's break it out. Mostly because I want to practice using let. Okay. That's my first cut of a solution. Let's, so this is a new chapter, so it's going to be set to be test.hs. And that's it. Smallest divisor. Return the smallest number greater than 1 that divides the given number evenly. Smallest divisor n. All right, so let's see. Do I need a helper function here? Probably, because I need to know where am I? Like, what am I actually using? All right, so smallest divisor of n is going to be smallest divisor. So we can do this two ways. We could start with the number and count back, or we could start at 2, since we don't have to work for 0 and 1, and go up. And then if we reach the number, then there is no smallest divisor. It's prime. I don't know offhand algorithmically which is better, but I'm going to choose to count up here. And that may, they say that we need this in the next exercise, so maybe I'll be revising this, but let's take a look. So smallest divisor n, starting with 2. Okay. Smallest divisor helper function. Okay. Helper function is going to go, it's going to take 2 integers and return an integer. Let's do guards here. All right, if nk. If n is equal to k, then that's the smallest divisor. Otherwise, if and mod k is equal to 0. 5? What? Then the smallest divisor is k. I think that's correct. Otherwise, smallest divisor helper, n k plus 1. All right, so we will stop when k is greater than, is equal to n. So it will terminate. The one wrinkle here I'm going to choose to ignore it because they say we don't need to do it, is what happens if someone passes smallest divisor 0 and 1. I'm going to ignore it for now, and maybe I'll regret that. Exercise 6 passes. Okay, well, let's go on to our is prime. I am deliberately leaving smallest divisor on screen because I think this is a good example of these two exercises go together. So I like the idea of pairing these up, and maybe these are the ones I'm going to use for set 2b. All right, 0 and 1 are not prime. So some people dislike enumerating cases this way and prefer to kind of move the logic to the other side of the equal sign or into a guard. I actually really like it. If I can just eliminate a case, to me, that's wonderful. Although in this case, you could have a guard, in fact, let's do it. Why not? Simply because I'm having my little reaction to this should be a natural number and not an integer. So we could say is prime n where n is less than 2. And that handles all the negative numbers, and that's not prime. So then we're only left with our other cases. Well, it's telling me to use smallest divisor, but I can't help it, man. Like, we know that even numbers are not prime numbers, so I'm going to do it. I'm sorry. I'm sorry if I'm violating the spirit of the algorithm. All right. So I think we can do this in one test. Smallest divisor. Can I use a where here? I guess I'm going to find out. Right, if we get back our n, then we know that our smallest divisor algorithm terminated without finding anything smaller than n. Well, fingers crossed. No. Is prime 17? Okay, so that's interesting. So we've somehow failed a given case. And since this is just returning true or false, that doesn't tell us much. Well, we can do this. We can certainly call smallest divisor. Let's see what we get. I have to load it. That seems right. Have I got the logic am I like completely failing to remember what a prime number is? If there is no divisor, then it is prime. Yeah. I literally got the definition of prime numbers backwards. I'm brilliant. I think then we don't even need this otherwise case. I think it might be, we might get a warning if we get rid of this. But let's take a look. I guess not, because no divisor is... I'm uncomfortable. I'm going to do it anyway. I have to have total functions. All right. Stack, run Haskell, set 2b test. Here we go. Is prime 2 expected true was false? Okay. What are we getting wrong here? Oh, because I literally have this here. And yeah, it's not the case that all even numbers are not prime. One even number is prime. So that was a bad test. So biggest prime at most. X. All right, that was super interesting. It took me longer than I thought to come up with an implementation that I liked. I went down some side streets of trying to use maybes for this and eventually decided that with the constraints on the problem, I could do it without it. I would love to see your solutions to this problem. So if you are so inclined, leave a message, leave a comment, and show us how you solved it rather than just looking at mine. This has been lecture 2 of the Haskell MOOC from haskell.mooc.fi. I've enjoyed doing some of these problems with you, and I will see you next week for lecture 3. You're watching Tea Leaves Programming. This is Haskell for Dilettantes. Thanks for watching.